Quick overview of what we will be covering today. We'll start out with Washington's volcanic hazards, followed by earthquakes, tsunamis, and then some preparedness information and a lot of great resources for you. And then with what time we have left, we'll go over any questions that have been submitted into the Q&A. And with that, I will turn it over to my colleague, Brian Turbush, so that he can kick us off with volcanoes.
Good morning, everyone. Thank you for being here today. Can I just get a quick sound check from Melissa?
Yep. Try that again.
Perfect.
I need to send you live.
All right. Can I get a quick sound check?
You're good?
Keep talking as I'm sent live. All right. Well, thank you again, everyone, for being here this morning and taking the opportunity to learn about your hazards. My name is Brian Turbush. I'm the Earthquake and Volcano Program Manager for Washington Emergency Management Division. So I am a volcanologist by training and a geophysicist is what my degree is in. So a little bit of background expertise on volcanoes and earthquakes, and here to share that information with you. I just wanted to start off by letting everybody know it's always good to have a content warning. Some of the things we talk about, some of the images we show, these are about disasters that might happen someday in Washington. So there's a potential some of them might be scary, but I appreciate you all taking the time to learn about them, because knowing about these things is the best way to help protect yourself from them in the future. So yeah, let's get started talking about volcanoes in Washington. So I like to start with this slide. Does anyone recognize this mountain? And I know the interaction is limited, but we got this nice kind of symmetrical cone-shaped mountain here, some good snow cover on it. It looks like it could be any of our volcanoes. Let's go to the next slide, please. So this mountain is actually Mount St. Helens. It is most famous for its, or infamous in many cases, by its May 18th, 1980 eruption that dramatically changed that perfect cone shape into what today looks like somebody took an ice cream scoop out of it in a very dramatic fashion when you have all this explosion of ash flying all over the place. So I'd like to start with that just to think about how all of our volcanoes in Washington, all of these mountains are such an important and iconic part of our skyline and of our culture, of our recreation in this state. But they have this potential to change dramatically. And that's a really important reason to learn about them, but also an important reason to go visit them while they are the way they are. Let's go next slide, please. So Washington has 5 active volcanoes. I want you to remember the number 5. Hope that's not too much. The reason we have these volcanoes, and there's some really nice art from our Department of Natural Resources there, so the U.S. Geological Survey has taken these volcanoes and looked at how often they erupt, how many people are potentially at risk when they erupt, and just kind of combined that and what kind of hazards they represent and divided them into different categories of threat, what kind of threat they represent. So based on that, Mount St. Helens, or Luet Laualatla in some of the native languages, is number 2 in the country. So they're looking at 161 different volcanoes that are considered active that have erupted in the past 10,000 years, which means they're all in the state of just add magma, and they could start erupting again. It's not too hard to picture that this could happen again. Mount St. Helens is higher than Mount Rainier only because it erupts so much more frequently, and we'll have an image of that soon so you can take a look. Mount Rainier, or Tahoma in some of the languages, is number 3 on the list. A lot of people, so number 3 on the list in the United States for highest threat. Mount Baker, Mount Kulshan, number 14, Glacier Peak, or Dagobah in some languages, number 15 in the language. So 4 of our 5 volcanoes are very high threat. Now Mount Adams, or Pop, be alerted for them, to be prepared for them, and to mitigate that risk to yourself. So next slide, please. Sounds like we might be having some sound issues, so got a nice pose of my hand there. Perfect. I see that the slide has advanced. Apologies, my internet is probably not perfect in here. I take a lot from where but I will keep talking and hope that it works well. I'm so sorry. Okay. So what we're looking at here is a graph of when eruptions have had a water rain over the past 4,000 years. So again, they're active if they've erupted in the past 10,000 years. However, just about 100 years of activity. And that is a sign that all of our volcanoes, except again, Mount Adams, have had eruptions time period. So all of our volcanoes, all of them in a period of time when the volcano was erupting. So not just one explosion like the May 18th day, but a period of explosions, of eruptions, maybe lava coming out for possibly more than 1 year. Okay, let's go to the next slide, please. I am going to try to connect to my hotspot and see if that helps.
Hi, folks. Sorry, looks like we're having some internet issues. Brian happens to be at a conference right now, so I know he's operating out of a side room, so it could be that he's having some internet trouble. So give us just a second and we will be back online with you.
Okay, I am sound check really quick. So sorry about these technical difficulties, everyone.
Yes, we can hear you.
Okay, I will continue then. Oh, yes, apologies, and thank you all for your patience. Okay, so I will not have my video on for this, but I will still wave my arms around for you, even though you can't see me. So I wanted to say volcanic eruptions are unique natural hazards. So they are very different when it comes to things like floods and earthquakes, which, I mean, we get some warning for floods. We know when the weather might be leading to that. However, when it comes to things like earthquakes, we don't get any warning. When it comes to volcanoes, we get an interesting amount of warning. It can be days, it can be weeks, it can be months, it can be years. However, they get really interesting because decision makers, your emergency managers, your sheriffs that might be evacuating people, they have to make decisions before we know exactly what's going to happen. So a big thing about volcanic eruptions is that there's a lot of uncertainty with them. So I like to look at this graph and see that on the left side we have the volcano's heartbeat and pressure, maybe the number of earthquakes that are happening at it. The number of earthquakes that indicate it might be moving towards an eruption, or maybe it's inflating. We'll talk about these signs and how they're monitored soon. But as those increase and it looks like the volcano might erupt, there's a number of things it could do. It could erupt very quickly, but it might also wait a while and just show those signs before erupting. Or it might not erupt at all. In some cases, that's what happens. That's what happened to Mount Baker back in 1975. It showed all these signs like it was going to erupt, and that led to things like closing the national forest around there. People couldn't camp there. People couldn't go to the ski area for about 6 months, and then it ended up just stopping showing signs of eruption. So all those things opened up again. But when we make these decisions about how to keep people safe for a potential eruption, it does affect the locals. It does affect the tourism in that area. Sometimes it affects the tourism a lot when a lot of people come in to try to go watch the volcano explode. We're probably going to get a lot of that in the next eruption, thanks to our kind of celebrity of Mount St. Helens. However, we know it's really important that people stay safe. So we have to make these decisions to keep people safe, knowing that they will impact the area, but also not knowing exactly what the volcano is going to do. So let's move on to the next one. Okay. So what's really important for getting to that step where we know the volcano might erupt, I'm going to call that a stage of unrest, is volcano monitoring. So our U.S. Geological Survey Cascades Volcano Observatory, located in Vancouver, Washington, and the Pacific Northwest Seismic Network that works out of University of Washington, University of Oregon, they monitor our volcanoes very closely. And I like to think of this as, you know, you go for your yearly checkup. And you find out just kind of what your heartbeat, what your blood pressure are that are normal. So you can learn when things are abnormal, when those things start to change. So yes, it's really important to watch our volcanoes over a long period of time. Some ways that's done, we've talked about seismic, just monitoring whether there's earthquakes, whether there's tremors, and all of our volcanoes have earthquakes at them. They're active volcanoes, and they've even found that some of them at Mount Rainier, with its massive amounts of ice, these are ice quakes. They're just the glacier bashing into each other. Now, these are small. You're probably not going to feel them. Very low magnitudes, 1 or less for the most part. What they do is look at those earthquakes, and on very well-monitored volcanoes, Mount St. Helens, Mount Rainier are two of the most well-monitored volcanoes on the planet, not just in the United States. So they can tell when something happens there. And what the geologists are looking for in that area is it doing something different? Are those earthquakes moving higher in the mountain? Are there more of them than usual? Because even some earthquake swarms are normal there. They're also looking for things that go along with that, like deformation. If you have GPS on a volcano, you can tell if it is growing. Anything that we're trying to look for here is there magma moving into the volcano? Because all of our volcanoes do not have eruptible magma right now. They're not ready to erupt. But if magma moves into them, that is how they would get to that point. So also looking for gases. All of our volcanoes do have gases coming out of them as well. So what they're looking for is changes in the gases. Maybe most of the gas that comes out of volcanoes is actually just water vapor, but there's other things in there like sulfur dioxide, hydrogen sulfide, which might be why you have that kind of rotten egg smell near some of the vents. Now, if some of those gases cut off, or if there's a lot more of them than normal, that might be a sign there's magma adding to those gases, because there's a lot of gases in magma. And also chemistry, temperature, there's a lot of water coming out of there in springs. If there's magma nearby, it might change the chemistry of those because the gases move into the water. Those streams might start to get warmer. So again, watching these all over time. And then once in a while, you can see that something is changing at the volcano, but it's usually going to be a combination of several of these things, which is why it's so important to watch the volcanoes. So next slide, please. So besides when will a volcano erupt, when will it start to wake up, it's really important to know what might it erupt. So in geology with volcanoes, it's important to think that the past is the thing you want to study if you want to understand the future and what might happen, what those possibilities are. Deposits from old eruptions help us to see what might happen in the future. So for example, here, I'm looking at Mount Rainier again. This is the deposit from the Osceola mudflow about 5,600 years ago. This is when Mount Rainier used to be a lot higher, about 16,000 feet high, and a huge section of it fell apart, just kind of like Mount St. Helens did in 1980, but in a lot less explosive way. Now, as a result of this, these mud flows, these lahars, traveled 31 miles downstream. This deposit is still 26 feet thick. So we know that Mount Rainier can have these absolutely massive mud flows down all of its rivers, and that's something we need to look out for at Mount Rainier. Next slide, please. So all of our volcanoes have these hazard maps created by the US Geological Survey. And if we look at these in a little more detail, so the pink area around the volcano, that's on the slopes. That's an area where there could be near volcano hazards. These are things like, I'll go into them in more detail, but the things you see in a disaster movie, these massive clouds, those are mostly contained to very close to the volcano. So in this case of Mount Rainier, you'll see that those are almost entirely contained within the national park. We like that working for the state because the feds can close it, and it's not our fault. It's their land. They can be the ones who close that. But if that area is closed, again, it is for your safety, and we'll share more. The things we look out for, especially because they can travel tens of miles downstream from the volcano, are these reds and yellows in the river valleys. These are lahars, or volcanic mud flows that can come off the volcano, leaving those deposits like we just saw in the last slide. Huge flows of debris and bridges and trees and ash and mud. So next slide, please. Something that is not considered on those maps, and I will go into those in more detail again, just what each of those hazards are, and then look at a map again after you're familiar, is volcanic ash. So volcanic ash is not the same as the ash that's flying around during wildfire smoke season, which is little tiny pieces of wood and carbon. Volcanic ash is little tiny pieces of lava that have been fractured by the explosion. Just the force is so strong it blows rocks into little tiny pieces. So small amounts of it are just kind of a nuisance. You really don't want to breathe in a lot of it, but it's not going to hurt you. But when we get to large amounts of ash, like the huge quantities that pumped out of Mount St. Helens in 1980, they can be dangerous. They can be dangerous if you're driving 4 inches, if it gets wet. As we know, it never rains in Washington, so we don't have to worry about that. But 4 inches of wet ash becomes heavy enough it can collapse most roofs. Again, you're probably not going to get 4 inches of heavy ash unless you're very close to the volcano, because it does spread out with the wind. But that is something to be aware of. It's generally very non-toxic in Washington. We don't have to worry about that much, but it does cause a lot of nuisance and can damage things like plane engines, car engines. Next slide, please. So as you can see, here's some images from 1980 Mount St. Helens where the ash went up into the atmosphere and the wind blew it all the way across Washington state. Now, all of our volcanoes have kind of different personalities in the way that they erupt. And Mount St. Helens and Glacier Peak are 2 very explosive eruptions that are volcanoes. The type of magma that they have, the type of lava that they erupt is a lot more likely to result in these big explosions. And they can dump a lot more ash. So for example, the biggest deposit of ash they found from Mount Rainier, even though it's a bigger volcano, it is not very explosive. It tends to have a lot more lava flows. The biggest deposit of ash they found it is only about 10% of the size of the 1980 Mount St. Helens eruption, which was a very large eruption. But so Mount Rainier, ash explosions, definitely not something we need to worry about as much. If the wind is blowing to the northwest, some of that ash could blow into Seattle and Tacoma and more populated areas and cause problems, again, as a nuisance level, because there's not very much of it. However, that is unlikely for the wind to be blowing in that area, just always a possibility. poor Eastern Washington is going to be the one who receives most of the ash that we get in the state from volcanoes. But again, you can see that driving here, it can be very hard to see. And if you turn your windshield wipers on to try to knock that ash off of your car, it might actually scratch them because it's little tiny pieces of silica or glass. Let's go to the next slide, please. So looking at near volcano hazards, these are things that happen close to the volcano. Again, that pink area mostly only on its slopes. Tephra is what we're going to call any heavy ashfall, any ballistics that come out. So these are just pieces of rock that are much bigger than ash that are flying out of them. Sometimes there's still molten lava when they're flying out. Those are called bombs. There are also lava flows here. In Washington, the type of lava that we have is a lot different than Hawaii. It moves a lot slower. It's very big and blocky. It's slow moving, but that can still be very dangerous because the front of it can fall off into these rock falls. Sometimes if there's gases in there, they can also explode out into pyroclastic flows, which we'll talk about shortly. But yes, you don't want to be near the front of the lava flow while it's happening. You don't really want to be in this near volcano hazard area because these are the most unpredictable hazards. One other one that's not on this sheet, but to think about is anytime there is lava near the groundwater, near the surface, even near rivers, you get a potential for a hydrothermal explosion where if that magma touches the water, it flashes the steam really quickly with a very violent explosion, which we saw in Biscuit Basin in Yellowstone earlier this year. That's an example of that where just really hot water suddenly exploded in a very violent way. And it was a miracle that nobody was actually hurt or killed by that explosion. That was really amazing. Very fortunate. So that is another thing that is really impossible to predict, but can happen anywhere there's very hot material near water. Please click. So here's just an example from 2018 when they were having some of these explosions at Hawaii. But kind of a funny example, something that was printed in a newspaper, but the idea is these volcanoes, when they start exploding, can throw these massive blocks at you, not refrigerators, refrigerator-sized boulders. So it's really unpredictable in these areas of near volcano hazards, and if they're closed, it is for your safety. That'll be my refrain for this. You don't really want to go in these areas. You see these videos of people walking up close to a crater, and then they are shocked when it explodes. You shouldn't be shocked when it explodes. You are near a volcano that is in a state of unrest. Next slide, please. And then the other near volcano hazard that can happen at all of our volcanoes is something called a pyroclastic density current or a pyroclastic flow. Hot avalanches of gas, rocks, ash. These are extremely dangerous. They're fast moving, they're unpredictable. And if they flow over the snow, they can start debris flows, they can start to melt it. These are the things you see in the disaster movies coming down a hill. Maybe you drive your vehicle into a mine shaft to try to get out of the way, but the best way to avoid these is just on the volcano when it's in a state of unrest or eruption, because these are really an unsurvivable hazard. So just don't be there when the volcano is in a state. Next slide, please. Now looking at our downstream hazards, again, those reds, those yellows, the hazards that can go miles downstream are lahars. These are volcanic mud flows. It's a mix of water, ash, debris that start to flow down when the snow melts. So lahar comes from, it's an Indonesian word. And in that area, a lot of the lahars start because they have plenty of volcanoes in Indonesia that have a lot of this volcanic ash on their slopes. And when monsoon season starts, all these rains fall on the slope really hard, and it can mobilize that ash and it flows down the river valleys. Ours in Washington, the way that they typically start is because we have so much snow and ice on our volcanoes. And when there's an eruption, it can start to melt that. And that causes a whole bunch of excess water to mix with that ash and move downstream for miles. So these are most likely to occur during an eruption, but they can very, very rarely happen without one. So they can travel miles downstream, tens of miles. They spread out in flat areas and river valleys. They're highly destructive. The lahars from Mount St. Helens in 1980 destroyed approximately 27 bridges. So they take out anything in their way. The only way to be safe when there's a lahar coming is to get out of the way. And something I want to emphasize here, if you live in a lahar zone, you might not be coming back to your home. Your home might be buried under 10, 20, 30 feet of mud. But what you can do is evacuate, and you can survive, and that is a really important thing. This is a hazard at all Washington volcanoes. The good thing about it is, again, it is confined to those river valleys. These are not going to flow up and over the sides of up and over the sides of streams, but again, they can spread out. So be aware that this is something that can happen when our volcanoes start erupting, and be aware of those areas. Next slide, please. So yeah, just an example of a lahar and what it looks like on a hazard map. Again, this is from the 1980 eruption of Mount St. Helens, and you can see this bridge is just completely buried. There's a little rock hammer sitting on top of that boulder in the foreground that shows just how big these boulders are that are lifted up by this. Again, you just need to be out of the way when these happen. But they're only going to happen in certain areas, and most likely to only happen when the volcano is erupting. So you can see, again, those reds, those yellows, these are the areas lahars have happened. These are the areas they will occur again someday. But again, it also doesn't mean that every eruption is going to cause all of these valleys to fill with mud. Like most hazards, it's most likely to have smaller versions of them. So those red areas very close to the volcano, it's most likely these are only going to reach there. But we want you to be prepared if you are in these areas, and be prepared for how you would evacuate, how you would get to safety if you were in these areas, just in case. Next slide, please. So volcano safety, let's get to that, because that's kind of what we've been talking about the whole time. The USGS Cascades Volcano Observatory has a list of kind of similar, like you might see for weather: normal, advisory, watch, and warning. All of our volcanoes are normal right now. A lot of them have earthquakes, as I mentioned before, but they are not proceeding towards eruption right now. USGS has established this over years, decades of monitoring them. If they start moving towards eruption, again, if those swarms of earthquakes or they start inflating, USGS might put them in a state of advisory. Like Mount Baker in 1975, that doesn't mean that the volcano is going to erupt, but it means that they're going to be watching it much more closely to try to help make decisions to close areas around the volcano, just to try to help us keep everyone safe. We know it is difficult when an area you really want to go is closed, and especially for an uncertain amount of time, like could be months, could be years. But they could also have a watch if the volcano is really ready to erupt, or there could be some situations where the volcano is erupting but doesn't pose any hazards to people. This happens pretty frequently at Kilauea, which is our #1 hazard volcano in the United States, over in Hawaii. But there's a lot of times that volcano is erupting, but it's only in this, it's contained within the summit caldera. It is not potentially impacting anybody. So that might just be erupting at a watch level. But if there's a hazardous eruption, one that might impact people, it's going to be in a warning state. So you can learn about these. You can sign up for a volcano notification service. And this is something that the USGS offers for free. You can get these alerts directly from them when something changes at the volcano. And you can sign up to receive them for all 161 volcanoes, and you will find out very quickly just how active Alaska and Hawaii are if you do that. Or you can sign up just to receive alerts for Washington, where you will not get nearly as many alerts, knock on wood. It could happen. Any of these could start erupting at any time. But again, just going to emphasize that again, it's the refrain of this whole presentation. If a national park or forest or any area around a volcano is closed, it's for your safety because of just the unpredictability during unrest. Next slide, please. So yeah, what can you do now? You're taking the time now already to learn about your volcano hazards. That's an excellent first step. Follow the guidance of your volcano monitoring agencies. Sign up for those alerts so you can know what's going on. Sign up for your local emergency management alerts to see if there is a lahar coming or something like that. Mount Rainier has a lahar warning system specifically for the Puyallup and Nisqually River valleys. That is because there is a small possibility of a lahar happening without an eruption. Again, in the last 10,000 years, this has happened in one case. But we know it is possible it can happen again. That's the main reason there is a lahar warning system. I'll have more about that in a second, but same as we're going to say for these other hazards, for tsunamis, for earthquakes, if you know you are in a hazard zone, there are things you can do to be prepared. You can practice your evacuation routes. And you can just understand that if you work or play in those or commute across these lahar hazard zones, they might impact you someday. But again, it is most likely it's only going to happen in the event that the volcano is in a state of unrest, in advisory and watch or warning. Meanwhile, Washington's volcanoes are so incredible, and please go visit them, go enjoy them. They're really unique environments. They're an important part of our culture, of our state for recreation. They provide these streams that are habitat for our salmon. The people who have lived here for thousands of years have amazing histories of these volcanoes and their stories. So please go visit them, visit the national parks and their visitor centers, and you can learn so much. Because again, they might change someday, but meanwhile, enjoy them the way they are. Next slide, please. What will our next eruption be? We can't predict what it will be. However, again, we have 5 active volcanoes, and if magma starts moving into one of them, it could be any of them. If I were betting, I would say St. Helens, looking back at that graph, it has erupted the most recent, or most frequently by far. It is number 2 hazard for a reason. But just take some time if you live around it to learn more about it, and you can be absolutely safe whichever of our volcanoes erupts next. Next slide, please. So to end volcanoes, I want to end on a very positive message, because we've talked about these lahars that can potentially bury entire communities, and this is something that's happened around the world. But Eastern Pierce County, the East Pierce Interlocal Coalition, every 2 years they conduct lahar evacuation drills with their students, with the teachers. So all of the students in the schools on the valley floor that are potentially at risk of lahars, they all get up and they walk their evacuation routes. They walk to high ground, or at the very least, they walk to a place where they can know what their evacuation route will be. They review it. And the students higher up in the valley, they review, they shelter in place like they would during an eruption in case there was ash flying. But it also helps protect, make sure that the roads are clear for the students who need to walk out, and for the rest of the community, in case people can't walk on their own, that need to drive out for emergency vehicles, keeps the road clear for them. The point is that all these students can do this, and this was a participation of 40,000 students and teachers last March when this happened. If all these students can do this, some of them have to walk 2 miles. They can do this in the time that they have. You can too. So take the time to learn and practice your evacuation routes, understanding that an emergency is going to be a very stressful time. But if you practice ahead of time, you get that muscle memory, and just know that you can get to high ground. You can do this safely. Yeah, and just as a note on that, 40,000 participants, that is the largest volcano drill that has ever happened anywhere in the world. So huge shout out to East Pierce Interlocal Coalition, which includes the city of Ording, which does actually annual drills. And they found even their kindergartners can walk to high ground. So you can do this. Just practice walking. And that'll be the end of the volcano section, but let's move on. Okay. And now we're going to move to earthquake hazards in Washington. So it's not just volcanoes. Washington also has the 2nd highest earthquake risk in the United States. We are right behind California for earthquake risk. So what is that risk? Again, this is the number of people exposed to hazards. So Alaska has earthquakes a lot more frequently than we do, but they have a lot fewer people that are exposed to those hazards. So Washington has the 2nd highest risk from earthquakes. Now, might not have felt one in a while here. I know a lot of people have felt the Nisqually earthquake, but we have hundreds of earthquakes per year, maybe even thousands. Just most of them are very small or happen in areas we can't. Again, we get a bunch of magnitude 1 or less earthquakes at our volcanoes every year. So why is that? It's because we live along this subduction zone, the Cascadia subduction zone, where the Juan de Fuca plate is spreading apart from the Pacific plate, and it is being forced underneath because it is more dense. This oceanic crust is very dense material, so it sinks when it runs into our continental crust, the North American plate that we sit on. So as it's there, it's forced under, and we get this friction buildup. Unfortunately, you can't see me because, it's not really a geology presentation unless you show a model with your hands. But if everybody can put their hands together like plates and slide them past each other until they get stuck, that part where it's stuck is where our plate is right now. Our plate is not moving. The North American plate is stuck to the Juan de Fuca plate. And someday it's going to overcome that force of friction, and all 700 miles of the Cascadia subduction zone, from northern Vancouver Island to northern California, like the Eureka area, are going to slip all at once, resulting in a magnitude 9 or higher earthquake. We know this happened back in 1700. It caused a massive tsunami that crossed the Pacific Ocean, caused land subsidence as the ground slipped down and lowered on the coast, especially. And yes, we've heard stories of this happening for, again, thousands of years from the people who have lived here. The story of Thunderbird and whale just having this fight that happens off the coast, just a massive geological event. Again, very scary to think about, but what we're going to talk about is how you can be prepared for it. This will change the face of the coast of Washington and the rest of Washington for years, decades to come. But what we can do now is actually take some time to prepare for it. Unfortunately, that's not our only earthquake source here in Washington. We have a couple others. Now, the one most people here in Washington have felt was back in 2001, or maybe in 1965 or 1949, when we've also had these earthquakes, these deep earthquakes that happen. So in the subducting plate, it starts to go down beneath the crust, and starts to dive down into the mantle as it subducts. And when it does that, it becomes brittle, and it gets to a point where it will bend and snap. I always throw that in for Legally Blonde fans out there. Sometimes the audience is a little too young, unfortunately, but that's okay. So when that snap happens, we get these earthquakes, magnitude 6.5 to 7.2 about is the range they can be. And that radiates upwards, and the whole area of Western Washington and British Columbia and Northern Oregon and Central and Eastern Oregon, or Washington as well, will shake as a result of this. It's not as intense shaking because it's so much further away, these being about 30 to 50 miles deep. However, this shakes a large area and it can cause a lot of damage. So again, most recently, this was our Nisqually earthquake in 2001, magnitude 6.8. It caused about $4 billion worth of damage. And about 400 injuries. Fortunately, no one was killed in that earthquake. However, so that's our most likely earthquake situation that's going to happen next. These happen every 30 to 50 years. Going back to the subduction zone, different studies, we found that these happen every about 250 to 600 years. And scientists say that there is about a 15 to 25% chance that it'll happen in the next 50 years. So there's still a very good chance it won't happen in our lifetime, but there's still definitely a chance it could happen this afternoon, next week, 2 weeks from now, 10 years from now, anytime. So good chances. I think the best response to those chances is to actually spend some time preparing, because we know it might happen, or these other damaging earthquakes might happen as well. We also have crustal faults. If you've heard of the Seattle Fault, the Tacoma Fault, the Southern Whidbey Island Fault, the Chelan Fault, these are all over the state, and they're just areas that are where there's surface expressions of how our crust is under a lot of stress as these two plates are pushed together. Now, it's really hard to tell when exactly these earthquakes might happen, because it is hard to find traces of them. But we know that the Seattle Fault last went at about AD 900. And we've also had an earthquake in 1872, the Chelan Fault, and that was our largest recorded earthquake, like historical record of earthquakes. But we know earthquakes have been happening here for tens of thousands of years, from the tracks of the faults, from the stories of the people here. So again, we have subduction zone earthquakes, we have deep earthquakes, the most likely big ones that happen next, and then crustal faults all over the state. We are on shaky ground. Washington is earthquake country, even if we haven't felt one in a long time. So enough time on this slide. Let's see the next one. So again, these happen all over Washington. You can see that Western Washington has a lot more of these. However, you'll notice, like in 2001, we had an earthquake swarm in Spokane. These can happen on the borders, like in the southern area. And then we can also shake as a result of earthquakes that happen in other states. The Hebgen Lake earthquake that happened in the late 1960s, that shook Western Washington a lot. That was an earthquake in Montana, kind of on the border near Yellowstone. And then some folks also felt the one in Stanley, Idaho, recently as well. So earthquakes are an entire Washington problem, even if a lot of it is categorized in the Western and Sound area. A lot of those are those deep earthquakes. However, we recommend being prepared anywhere you are in the state. It'll also help if you go visit somewhere else, because there's other places that shake too. Next slide, please. So it's really important to know what you might expect when an earthquake happens. We are so used to the ground being stable beneath us, it can be very scary when it suddenly starts to shake. Um, and that's what happens in earthquakes. There might be a roaring sound. Some people say they can hear an earthquake ahead of time. That might just be the P wave, which is the wave that doesn't do much damage, but it's basically a sound wave moving through the crust. We'll talk about how that one's useful in a little while. But there might be lights flickering. There might be sprinklers and fire alarms activating. Objects falling off, flying off the shelves, shelves falling over, furniture becoming overturned. Different levels of shaking are going to get different things. Different intensities. And yeah, people might be screaming. People might be very scared when this happens because it's a scary thing to experience. But knowing what to expect and knowing what you can do about it, which is what we're planning on talking about here, can really help you to make sure that you stay safe as possible, and your family and friends and pets do as well. So next slide. A really important thing we want to say here is do not try to run while the ground is shaking. I know there might be an impulse to get up and try to run out of the area as quickly as possible, but most of the injuries that have happened during earthquakes in the United States are from people falling while moving during shaking. You try to put your foot down and the ground is not where you thought it was. It's really difficult there. The other injuries are caused by being struck by falling objects. And if you're up and you're running, you are a big target, and it is really easy to be hit by falling or flying objects. So what we're going to recommend is drop, cover, and hold on. Hopefully you've heard this recommendation before, but we just want to show you that this is backed up by research. Most people that have been injured, and when we say injuries, we are including people who have been killed. These are by people who are falling during the shaking or struck by falling objects. So being out in the open is not a safe place to be during an earthquake. I mean, unless you're out in a big field or something where there's no hazards around, still getting close to the ground is going to help prevent you from falling. So that's the drop part. Next slide, please. So let's look at measuring earthquakes really quickly. Magnitude and intensity. This is the hill I will die on. Intensity is way more important than magnitude. But if we look at magnitude really quick, so they used to use a Richter scale to compare the size of earthquakes. And there's moment magnitude now, which is just magnitude is a measure of how much energy a fault releases during an earthquake. So you might have heard like a magnitude 5, 6, 7. Now, if we start with a magnitude 6, we're going to look at the areas of these circles here. Every time that you increase the magnitude by one whole number, this is a magnitude or a logarithmic scale, it increases the energy release by about 32 times. So if you go up from a 6 to a 7 is 32 times more energy release than a 6. Now, if you go up from a 6 to an 8, that's 30. Earthquake intensity. I mentioned before how our deep earthquakes, they don't shake quite as strongly as a magnitude 6.8 earthquake right on the surface. Because that one is so close, you are right there, and there's no time for the earthquake waves to attenuate, to lessen in their strength as they move 30 miles through the crust. So intensity of an earthquake is affected by where you are, how far away you are from the fault, what type of building you're in. Some buildings will shake more strongly than others. Generally, if you're on granite, if you're on bedrock of any type, not just granite, it's not going to shake as strongly as something like being on loose soil. Loose soil will always shake a little more strongly. So each earthquake has one magnitude, but many, many intensities, and this is shown on something called a shake map. Let's go to the next slide, please. So shaking intensities, again, this is the description of how much it shakes, but also what people experience. These are measured by the modified Mercalli intensity scale. So they go from not felt at all, which might be this earthquake was a long ways away from you. You didn't feel it. Or even if it was far away, it might have only been weak shaking. Only a few people would feel that. So let's look at a situation where maybe a large earthquake happened, but everybody that experiences that earthquake or doesn't is going to experience a different intensity. And each of these levels here is associated with a ground acceleration, which can be measured as well. But I'm not going to put those on there because it's really hard to think about like what 0.2 g is for acceleration. That's really hard for us to picture. What is easier for us to picture is, oh, that woke me up, or oh, the books fell down, or my couch flipped over. So I like this scale because it really describes what to expect in an earthquake. Let's go to the next slide. So examples of this are in shake maps, and these might show a scenario. Like, for example, this is examples of a shake map for Washington that might happen from that magnitude 9.0 earthquake that we've talked about, this subduction zone earthquake. So you can see that there is actually along the coast of Washington, we can get some of this extreme and violent shaking. And you can see that it's different in areas. That area where the Olympic Mountains are, there's a lot of bedrock there on the peninsula. So that's going to attenuate some of the shaking. It's not going to be as strong. Whereas on the coast, where we get a lot of these sandy deposits, it's going to shake a lot more hard. So you have that red color versus the yellow. And then looking at this Seattle area, north of there's deep sedimentary basins, which are going to shake much more strongly. Now thinking about this, our Cascadia subduction zone magnitude 9 earthquake, these intensities of shaking might last 4, 5, 6 minutes of shaking. So it's going to be a long time that we're exposed to these. But I'm sharing this because it's important to know what to expect. We'll talk about what you can do about it soon. In general, that intensity you're going to see is going to drop off to lighter shaking, again, for 4 to 5 minutes as we move towards eastern Washington. The further away you are, the less strong the shaking is going to be, less intense. Next slide, please. So here's an example, again, of why you should not try to run during an earthquake. I'll just say this about the Nisqually earthquake that happened in 2001. It happened at between 10 and 11 a.m. on a Wednesday in February, February 28th. Now this earthquake, again, 400 people injured by it, $4 billion in damage, but no deaths. Now, if this was something that happened on a sunny Saturday in the middle of summer, where all of these buildings are like in Pioneer Square, so many people would have been out walking on the sidewalk, and you can see just how many bricks fell off of these buildings straight into the sidewalk. Now, if you're running out of that building, you're also putting yourself in so much danger from that, from breaking glass, falling outside the building. And if you're on an upper floor trying to run out of the building, you are running downstairs, which are so many hard, sharp surfaces that you can fall on when they're moving. So again, we're going to talk about why you drop, cover, hold on, but this is part of the reason you do not run. We were very fortunate that earthquake occurred when it did, and that nobody was more seriously hurt, because this caused a lot of damage, especially to this type of building, unreinforced masonry. Interesting with this photo, we had an engineer join our staff for a brief time, and they pointed out that the building next to it, that yellow building, you can see between the sets of windows, there's these little dots, and those are called rosettes. And while these are both brick buildings, those rosettes indicate that the bricks have been secured to the floor of the building on that level, to the floor, to the ceiling. And you can see that that simple step of just securing those, this building did not peel away despite being the same construction as the unsecured Phoenix Underground Cadillac Hotel in this famous image of the Nisqually quake. So there are things you can do to mitigate the damage here, and we'll talk about those soon too. So next slide, please. Just want to show again what to expect in an earthquake. So this is an example from New Zealand. The slide did not advance based on mine. Can we try to advance again, please? There it is. Okay, so watch the upper right-hand corner in here to see just how quickly this can happen. This is an earthquake in New Zealand. And just watch that wall peel right off. Yeah, this is one of those scary images I was talking about, because this is something that could happen. Just how quickly this goes from 0 to shaking very hard. I mean, you can see the people here, and in New Zealand at this point, there have been thousands of aftershocks. So people are very familiar with what to do in this situation. You notice they stepped out into the streets away from the building, and then just kind of stand where they are. They're not doing drop, cover, hold on like we recommend. Which is really something that we recommend, especially because most of us have very little experience with earthquakes. At this point, they've had thousands there. And let's advance to the next slide, please. But I just want to share that as an example of how quickly this can happen. So one tool we have here that could help, because this can happen so quickly, is a tool called Shake Alert. And all of you here on this line, if you are in Washington, if you're in Oregon, or if you're in California, have Shake Alert, the USGS's earthquake early warning system, on your phone, whether you know it or not, but I'm going to help you find it. So this is not an earthquake prediction, but this is a system that can help give you seconds of warning before that shaking arrives in your situation. So when an earthquake starts, it releases P waves and S waves. I talked about P waves earlier, basically these sound waves that move really, really quickly through Earth's crust. And sometimes people can hear them, sometimes they might rattle the dishes, but the important thing about those is they're extremely fast. They contain a lot of information about what the earthquake might be, but they do not cause much damage. They just kind of move through the ground really fast. So USGS has spent a lot of time putting out seismic sensors. And when that P wave travels through 4 of these sensors, that's all it needs. It can detect and figure out what the earthquake magnitude is going to be, and it can send out a message to areas that are going to be shaking as a result of that earthquake before the more damaging S wave arrives, which travels about half the speed of the P wave. So the S waves are where you really get this shaking that does damage. These are shear waves. They travel up and down, side to side in the crust. They can't travel through liquid, but they travel slower and do most of the damage, those in surface waves. So what this does, again, detect an earthquake and alert people who are going to shake as a result of that before the shaking arrives, potentially. Now, because it's after the earthquake starts, it's only seconds of warning. But we find that through looking at a lot of things, a lot of people, this is kind of like research, looking at CCTV footage, listening to people's accounts of earthquakes, they spend the first couple seconds of an earthquake going, what is that? Is that an earthquake? So what's really helpful for this, even if you get that message after the shaking starts, it's confirmation that this is an earthquake and you need to protect yourself. So let's go on to the next slide, please. So in Washington, we have 3 different ways to receive these earthquake early warnings. Like I said, it's already on your phone if you have wireless emergency alerts turned on your phone. If you've ever gotten an Amber Alert, you can receive earthquake early warning through Shake Alert system. Now, one thing I want to say here is the fastest way you can get these on an Apple phone. If you go to your emergency alerts and click on that, you can turn on local awareness, which is a toggle there. And if you go to our mil.wa.gov/alerts page, which we will link to in the chat, there's like screenshots that show how to find this just to make sure you have it. But that is the fastest way to get this on an Apple phone, besides downloading the MyShake app, which is an option. If you have an Android phone, if you don't turn on that local alerts with your wireless emergency alerts or WIA, sometimes these arrive a little more slowly. However, if you have an Android phone, you have built-in earthquake alerts on your phone as well. What's really nice about that is you can actually test it. You can press a button that demos. No download required, just make sure it's turned on. And just recently, within the past month, Android has released their alerting throughout the entire United States. So anywhere you go, you can get these Android alerts if you have an Android phone. Unfortunately, that's not available on all phones yet. But the system in Washington, Oregon, and California specifically uses the USGS network of sensors. In other states, it actually uses the phone to detect earthquakes, which is mixed results. It's going to work better where there are more phones, but here in Washington, Oregon, and California, the system is going to work equally well wherever you are because there are seismometers all over the place. That's something we have built up over years. And then finally, you can also download the MyShake app. The reasons I would recommend doing this, if you would like to download an app, MyShake allows you to see other earthquakes around the world, which is something that plenty of other apps allow as well. There are so many apps out there that can do that, get data from USGS. However, MyShake is the only one of those that will actually give you seconds of warning before earthquake shaking arrives in your area. That's the only one that requires download. And the other thing with MyShake is they're the only one that actually sends a test message for the Great Shakeout drill. So that's a time to practice what you would do if you got that alert. However, this is already on your phone, and if you go to mil.wa.gov/alerts, we want to make sure that you know what those alerts are going to look like so you can practice with them so that you can see what happens and know how to use them. So next slide, please. Yeah, these will not alert you for every earthquake. They have thresholds. They're only going to happen for magnitudes higher than, like, say, 3.5, and only for intensity shaking in your area, light or greater, and it depends on the area. But so you're not going to get this for an earthquake that is not going to affect you. If you get that shaking, or if you get that alert, it means it is time to protect yourself. It might still be a small earthquake that only causes light shaking in your area, but hey, if you got that alert, you do your drop, cover, hold on, you practiced. The thing is, it doesn't tell you how big the earthquake is. All it tells you is it is an earthquake of light shaking or greater, which means it could be much bigger. It could be this violent or extreme shaking in your area. It's the only warning you're going to get. It is time to protect yourself when you get that alert. Next slide, please. So some other ways that this could be helpful is it doesn't only send alerts to phones. We have license to operate partners, and these are like technical uses. So working on building this out, but it's going to take decades. Things like slowing trains when they get this alert to cause fewer injuries, to cause less likelihood of a high-speed crash. Opening elevator doors on the nearest floor so that people aren't stuck in elevators. Opening firehouse doors so that people can respond. There's a lot of PA systems in schools in Washington that are using this as well, because maybe students aren't allowed to use their phones in school. So it'll announce over the PA that it's time to protect yourself. There are so many applications where this can be used for hazard mitigation and to make recovery after an earthquake faster. It's going to take a long time to get those out, but yeah, if you want more information about this, please reach out. If you have an application in your agency, at the moment, it does cost money to install these things. I think there is a grant for school PA systems, but other than that, and there may be grant opportunities for other systems as well. But yeah, we have this in a lot of water and wastewater in Washington as well, to make sure that there's going to be clean water available after an earthquake, help prevent water from leaking out of broken pipes, shut down the pumps so the stations don't catch on fire. This can be very important and a very epic system for making sure that we have things available and recover from an earthquake well. So next slide, please. But again, as I've said about this, it only works if you actually use it to protect yourself. We've seen CCTV footage in California where they've had over 35 earthquakes that have used the system, delivered the messages to people, delivered it to millions of phones. And there's some situations where people get this alert and they don't know what to do, which is why if you take one thing out of this presentation today, I want you to know you have this on your phone, and please use it when you get those alerts, because it's not very helpful if you get this alert and you see, hey, what's this alert? I don't know what to do. We're going to have an earthquake. And then the ground starts shaking and you haven't used those seconds wisely. So please learn. Please take some time, visit mil.wa.gov/alerts, find whatever's going to work best for you for message alert delivery, and practice what it's going to sound like. You can use the Great Shakeout and practice with it. Practice with that sound so you know to react when you get it. It's all part of muscle memory. So next slide, please. Okay, so when you feel shaking or get an alert, what do you do? Mentioned this a few times, but it's really important. Very simple 3 steps. They depend on your situation, but it's always going to be drop, cover, and hold on to minimize your damage in the best way possible. Minimize the amount of exposure to hazards. So when you drop, you lower your center of gravity, you get close to the ground, you make it so that if you're knocked over by the shaking, you don't fall as far. And it makes it harder to knock you over in the first place. You're also smaller when you're low to the ground. Covering your head and neck is so important if you want to avoid injury, and take cover under something sturdy as possible. I didn't include them in here, but I know a lot of people are like, well, what's a desk going to do to protect me? And we have pictures of, in classrooms, the 1985 Mexico City earthquake, floors of a building being held up by desks. It's like that bed of nails principle too, the more things that are above you. But still, just go try jumping up and down on a table. well, maybe I won't recommend that. But if you are, something you can do on a sturdy table, get near the legs of it, because those are the legs are really designed to prevent anything coming up above. It's going to provide a lot of protection from straight above you, basically. I'm sorry, that was a little confusing the way I said that, but the closer you are to the leg of the table, the better protection you're going to get from anything falling from above, because that's specifically what a vertical piece of wood is designed to do. Now, again, taking cover under something sturdy is important. If the only table nearby you is a wicker table or a glass coffee table, that might not be ideal, and just grabbing a book off that table is probably going to provide you slightly better cover. And then hold on is the third step, and that's about staying in the position you're in, but also holding onto that cover, because strong shaking can actually cause that cover to shake away from you, and you want it to stay above you if you can. So hold on to the leg of that table, that desk, keep it above you. So you lower your center of gravity, cover your head and neck, take cover if possible, hold on to that. Now, you're not always going to be near a table, and there's different ways that this works. So think about the places you spend the most time. If you're in bed, you're going to want to kind of roll over. You want to cover your head and neck with your pillow. Now, in bed is actually the place that most people are safest during an earthquake. You're not getting up, you're not running away, you're not falling because you're not high to the ground. You got kind of a place. And also in bed, there's fewer injuries if earthquakes happen at night, generally in the US, because fewer people are out driving, which can be dangerous. Now, if you're outside, you saw the folks in New Zealand kind of stepping away from buildings, stepping away from those power lines. I'm still going to recommend getting low to the ground, because when you feel that first wave, they were pretty sure that earthquake's going to be small, not going to knock them over, but it could be very strong. So getting low to the ground is going to prevent yourself from getting hurt. If you're driving, there were a lot of folks who talk about their Nisqually earthquake experience. They were driving, they're like, oh, it suddenly felt like I got a flat tire. Now, if you get a flat tire, you slow down, you pull over to the side of the road. Same for an earthquake. You try to avoid, again, those things that might fall, telephone poles, electric wires. Try not to be on a bridge, but you can't always control that. And our bridges are all being retrofit to be able to stay up during the earthquake shaking as well. And then wheelchairs, walkers, there are some people who struggle to get down to the ground on their own. And in that case, this hold on is going to be really important. But when you think about drop or locking your wheels to try to minimize that movement, the important thing there is trying to prevent yourself from being thrown to the ground, from getting to the ground in a way that is not your own volition. So hold on closely. You can cover yourself with your walker if possible. Have a sturdy book or something on there. Yeah, wherever you are, you want to be low to the ground. You want to be a small target for things, and you want to hold on as much as possible. So think about the places where you spend the most time and apply drop, cover, and hold on in those ways to those places, because we can't predict an earthquake. We don't know when it's going to happen. But if you think about the places where you spend the most time, those are the places you're statistically most likely to be during an earthquake. And I'll give you a statistic here right now. If you sleep 8 hours a night, there is a 33% chance you're going to be in bed during the next earthquake, in your bed. So what can you do now? Is that area safe? Do you have frames on the walls? Do you keep your bowling ball collection by your bed? I have a friend who collected these really cool replica Lord of the Rings swords and put them on stands above her bed. And when I was helping her move, we decided, no, you're not going to put this above your bed, not in earthquake country. Your bed is generally the safest place if you keep things there. So that's really good. If there's a 33% chance the next earthquake is going to strike while you're there, or drop it down, you only sleep 6 hours a night. There you go, 25% chance. Let's go to the next slide, please. Okay. So when we talk about what can be done about earthquakes in Washington, I hope I covered drop, cover, and hold on, and mitigation steps in exhaustive detail, as well as the science behind earthquakes. But the thing I want to get out of that as well is there are steps we can all take to try to make our spaces more safe from earthquakes. And the Earthquake Country Alliance, a site out of California, I can put the link in the chat for that. They have very good resources on how to secure your space and make sure that your home, your work, your office, your school are going to be very helpful for, they're going to be as secure as possible when an earthquake strikes. But let's look onto what Washington State is doing as a current project to try to keep our buildings safer. We have a lot of these unreinforced masonry buildings or old brick buildings, like you saw the Cadillac Hotel in that image. These can be very dangerous in an earthquake. And we know that we have anywhere between 6,000 and 30,000 of these buildings, possibly more. around the state. So Washington State is working with, our Emergency Management Division is working with Department of Archaeology and Historic Preservation, with Commerce, who created a database back in 2018, and a lot of other agencies, especially cities, to try to catalog these buildings brick by brick. No pun intended there. But we want to create an interactive database that shows where these buildings are, so people know. But most importantly, we want to help owners understand what the hazard is of those buildings, that they are dangerous, but then even more important, to connect them with resources that will help them retrofit those buildings. Because fixing them, whether it's at a level where you're just installing those rosettes, fixing them to the foundation, to the floor, or whether you're doing a lot more, whether you're bracing the building internally, this can be very costly. So we want to make sure people have, the building owners, whether they're publicly owned, privately owned, have the resources they need to fix these buildings, because a lot of these buildings they might be schools, they might be hospitals, they might be other buildings that are going to be important to emergency response, or just important community buildings. They can be vital to the economy of a community. So we want to make sure that these buildings are safe, one, so people aren't injured or killed during the earthquake by the bricks falling off these buildings, but then so that the community can actually recover better. So this is a work in progress. It's going to take a long time to inventory these, but you can see some images here of the project that was done in Everett last April. We'll be working with the city of Tacoma soon to do another one. But yeah, we are really hoping to have this out and ready. And then huge thanks to Department of Archaeology and Historic Preservation for their help on it. And yeah, for now, that is all we have for earthquakes and the opportunity to learn about that. So thank you for bearing with me in the technical difficulties, and I am going to pass you back to Alyssa to talk about tsunamis.
Awesome. Thank you, Brian. I am just getting my camera turned on here. Can everybody see me? Or Brian, can you see me?
Can see you just fine. Thank you.
Awesome. Well, thank you everyone so much for hanging in there with us with our technical difficulties. That's one of the many wonderful things about living in Washington, is sometimes we are in areas of not great internet or cell reception. So I will dive right in. As Brian said, Washington is earthquake country, and that means that Washington is also tsunami country. We have 3,000 miles of beautiful shoreline with an extremely high risk outer coast, a very complex, narrow inner coast, 31 ports, including the ports of Seattle and Tacoma, which together make up the 5th largest container gateway in the entire United States. We also have 7 Coast Guard stations and 4 Navy bases, the largest ferry system in the United States, 5 coastal oil refineries, and anywhere from 175,000 to more than 300,000 people living, working, and recreating in tsunami hazard zones on any given day. So a lot of really important things along our shoreline, on our waters, that we really don't want anything bad to happen to when we have our next tsunami. So what exactly are tsunamis? So tsunamis are essentially big waves that are caused by any displacement of a column of water. They are usually caused by earthquakes, but can also be caused by landslides, volcanic eruptions, certain weather events, very rarely big meteors, anything essentially that is moving that full column of water. So in the little video that you can see on the screen, that's specifically showing the kind of tsunami that's created by subduction zone earthquakes. So Brian was talking earlier about the Cascadia subduction zone and how those plates get locked. He couldn't show you because he didn't have his screen on, but when they get locked, you know, they're stuck in place, and then when enough friction builds up, that plate pops up, and when it does, it lifts that entire column of water, which can be, you know, a mile or more of water that then is moving out in all directions. And so when we think about tsunamis, they're not like normal wind waves. It's that entire column of water that's moving. And so they're really a series of waves because they are that rippling out. And they can last anywhere from 12 to 24 hours or more, kind of depending on how big that event was that caused the tsunami. Something to keep in mind is that the first wave of a tsunami is often neither the highest wave nor the most destructive wave. Some of our modeling for Cascadia specifically shows that it could be that third or that fourth wave that's the largest. They are also very fast, and very powerful. So they are not so much like wind waves or like water waves, as they are more kind of like a moving wall of cement. They pick up everything in their path, meaning that that water could have boats and houses and buildings and logs and trees, all sorts of really dangerous stuff in it. And then they leave all of that debris behind. So when the waves themselves are no longer a hazard, we still have a lot of cleanup and potentially a lot of mixed and very hazardous debris to deal with. Major tsunamis, like the kind I'm mostly going to be talking about today, are very low probability events, especially for Washington, but when they do happen, they can be very high impact for us. So because we have 3,000 miles of beautiful shoreline, we are at risk from both local and distant tsunamis. So local tsunamis are ones that are caused by something here in or very close to Washington. So that is usually from an earthquake that is caused by one of our fault lines here in Washington, or potentially, a very localized landslide, maybe in the Puget Sound, something like that. So if it is an earthquake, that's one that we're going to feel that shaking. It's going to be close enough that we can feel that. And therefore, that shaking really is our first warning that a tsunami is on the way, our best warning that a tsunami is on the way, and potentially, depending on how soon those waves are going to be arriving, it might be our only warning. The way that local versus distant is defined is essentially, for a local tsunami, those waves are going to be arriving on our shores in less than 3 hours. Because they arrive very quickly, there's more inundation on land, much more severe currents, bigger whirlpools, things like that. And so they have a much greater impact to our coasts. Our biggest local threat is the Cascadia subduction zone. That will impact our entire coastline, both the inner and the outer coast. But we also have more localized threats along the inner coast from those crustal faults that Brian was talking about. So the Seattle fault zone, the Tacoma fault, the South Whidbey Island, those have been known to generate tsunamis in the past as well. Now, our distant tsunamis, those threats are coming from somewhere else in the Pacific Basin. Potentially from Alaska, Japan, Chile, somewhere else that's also having those big earthquakes. And so because they're very far away, we don't feel that ground shaking. And so we need official tsunami alerts to tell us that something is on the way. Otherwise, we're not going to know until it's potentially too late. Those waves are going to arrive in over 3 hours. That's what makes it a distant tsunami. But if it's something coming from, say, Alaska, it may be 3.5 hours or 4 hours. That's more time for folks to evacuate and to get to safety, but that's not a ton of time. That does mean that those waves, the energy of those waves has dissipated a bit. So there's less inundation. The currents are lower. We may not see the big whirlpools that we will see for Cascadia. So there's less of an impact on our coast. But there is still a threat to our outer coast. Our biggest distant threat is Alaska. I'll talk about that in a little bit. Not really a threat to the inner coast, but something we still want to pay attention to for our outer coast and kind of into the Strait of Juan de Fuca. Come on, slides. There we go. So Brian talked a bit about the Cascadia subduction zone. Again, it's about 700 miles long, stretches from Northern California to Vancouver, breaks every 300 to 600 years, kind of depending. It can either do a full rip of that full 700 miles, or potentially kind of little bits along that subduction zone. The last great rupture was in 1700, so we are within that window, so to speak. We have about a 15 to 25% chance of having an earthquake on the Cascadia subduction zone in the next 50 years. When we do, that's a big earthquake. We're talking, 8.0 to 9.0, potentially larger. So something very big that we're all going to feel the ground shaking for, and that is going to generate a tsunami. Potentially, if we're thinking like a 9.0 earthquake on the Cascadia subduction zone, we can expect anywhere from 3 to 6 minutes of ground shaking throughout the state, especially if you are on the coast, if you're in the Puget Sound or anywhere in Western Washington. That's a really long time. If you did experience the Nisqually earthquake, depending on where you were, that was anywhere from 30 to 45 seconds. I did feel it. I was in 7th grade and it felt like forever. So when we think about 3 to 6 minutes, especially of really intense, really violent shaking, that's going to be something that really rattles our brains. And for those of us who then have to get to high ground right after, knowing a tsunami is on the way, that's going to be really challenging. That initial earthquake, the minute that starts off, is going to be followed by a major tsunami that hits our outer coast in some places in potentially 10 to 15 or 20 minutes. And that includes that 3 to 6 minutes of shaking. So there are a lot of areas on our outer coast that do not have a lot of time to evacuate. That wave then travels through the Strait of Juan de Fuca and into our inner coast. So it touches everybody. Like Brian also mentioned, we will have a permanent change in our coastline. So we'll have areas that subside or drop down. We'll have areas that uplift. So it'll really change how we interact with our coastline. And then we can expect a lot of aftershocks that will follow that main quake in the days and weeks and months to follow, and then smaller ones for many years after that. So this is not going to be just one big event that we then get to put behind us. It'll be something that we continue to deal with for a long time. I just want to make sure this is going to play. Okay, awesome. So this is a truncated version of a video from the Washington Geological Survey. It's showing, again, that for that 9.0 earthquake and tsunami, what those tsunami waves look like. So you have the time since earthquake, it's sped up. And then you have the wave amplitude. So those warmer colors getting into that dark red, that's a wave height of 10 feet or more. So it caps out at 10 feet, could be 20 feet, could be 30 feet. And then getting into those cooler colors, that's 10 feet or lower. So a trough, or when the wave pulls out, potentially, areas where we might even see the sea floor before that next wave comes in. Something I really like about this simulation is that, one, it shows how quickly that wave first arrives, but you can also really watch that wave travel through the Strait of Juan de Fuca. It starts with that trough wave, and then you can watch it split, go down into the Puget Sound, north up into the Salish Sea, into the San Juan Islands and that area. And you can watch how it really kind of bounces off all of our, twisty, turny corridors in the Puget Sound. So again, this is a tsunami that is going to impact every part of our coastline to some degree or another, and is something that we are going to be dealing with for a long period of time. It's going to be, many hours, potentially many days before those currents have really slowed down and kind of returned to normal. This is the kind of full state simulation, but Washington Geological Survey on their YouTube and on their website have also kind of zoomed in versions for different parts of our coastline, and then also have similar simulations and graphics for the Seattle Fault. So if you've never seen this before, I recommend checking out some of the other simulations. They're really interesting. They've also got the same area simulations for current speeds too, so you can see where we start to get those whirlpools or those areas of really kicked up currents. As Brian mentioned, we also have our crustal faults in the Puget Sound, and those have been known in kind of the more distant past to generate tsunamis as well, if they cause earthquakes that are strong enough. We usually need something like a 7.0 or higher to really generate enough force to cause a tsunami. And so we do have that along the Seattle Fault, Tacoma Fault, South Whidbey Island Fault. Unfortunately, we don't know as much about these faults and kind of their tsunami history as we do Cascadia. So we're still learning a lot about them and still kind of modeling them, figuring out what that tsunami threat looks like. But when we look at Seattle, which is kind of the one that we are focusing on right now, that we have the most information for, we do know that in the past it's generated tsunamis, the most recent being in 930. The north side of the fault lifts, or sorry, north side of the fault drops. The south side lifts up, so it's going to have more of an impact for the North Sound than the South Sound. And when we model for this, and when I show you kind of the graphics in a second, that's for something like a magnitude 7 or a 7.5, which for this particular fault zone would be kind of the largest earthquake for like a 7,500 year period. So we're talking really maximum considered scenario, very low probability in any of our lifetimes. But we want to know what that hazard is. We want to make sure that we are aware of, you know, what that risk is, where those areas of inundation might be. And to give you an idea of what that looks like, so this is the Bainbridge Island area, and you can literally see through LiDAR, so removing all the, you know, trees and buildings, you can see that fault very clearly. And we have areas that were uplifted the last time and look very much like something did push them up. Make sure these are both going to play. There we go. So when we're talking about local earthquakes and tsunamis, especially something like Cascadia, those have a lot of impacts here. Tsunami waves, along with, you know, landslides, liquefaction, or the way that the earth kind of turns watery during that ground shaking. Those can really mess up our infrastructure. They can damage fuel piping systems and pumps, cause power loss even outside of the areas that have been affected by the tsunami. We expect to see a lot of damage to our bridges, overpasses, roadways, and kind of all of that other really vulnerable transportation infrastructure that was built before we really understood our big Cascadia, you know, hazard here. We'll also obviously see a lot of impact to our marinas and to our maritime infrastructure because we really haven't dealt with that tsunami risk there. So we can, you know, imagine that we'll have a lot of impact to our supply chains and to getting goods in, but also to getting goods out as well to the other states and places that rely on what we send out. So the two videos I've got here are from the 2011 Japan tsunami. That really is our best sort of real world event to look at when we're trying to imagine what Cascadia might look like for us. It was a very similar setting geologically, very similar kind of earthquake and tsunami to what we can expect. So when we think about what that might look like, especially on our outer coast, looking at, you know, videos and impacts to Japan is kind of the best thing to do. So you can see here, you know, the amount of inundation moving these huge ships, you know, basically through city streets, big whirlpools we can expect. Definitely don't want people to be out on the water during that. And Japan saw quite a bit of damage, you know, over 2,000 roads and over 50 bridges destroyed, 319 ports closed. Most of those have reopened now, but not all of them. So when we think about Cascadia, that's definitely going to be something that impacts our whole state. And here are just kind of some images again from Japan to kind of get us thinking about what that major scenario could look like. And this is a before and after of one of their coastal towns. So let's talk about natural tsunami warning signs. So when we have something coming toward us, either happened locally or maybe it's a distant tsunami and we just have not gotten any, you know, official tsunami alerts or anything like that, there are things we can look for. The first obviously is that ground shaking. Any, you know, long or strong ground shaking when you're at the coast is, again, your first warning a tsunami might be on the way, your best warning a tsunami might be on the way, and potentially your only warning. There's really no way to know if you're feeling strong shaking, whether that's an earthquake that's going to cause a tsunami, unless you're, you know, they're counting out on your phone. Okay, that seems like long enough to have been Cascadia, or oh, maybe not. Maybe that was Seattle. You're not going to know. So what we want you to do is just assume that that could generate a tsunami. But maybe you don't feel ground shaking. you might notice something else. You might notice a sudden rise or fall of the ocean if the water pulls out really quickly, much too fast for a normal tide. You might hear a roaring sound coming from the ocean. I've heard it likened to kind of like an approaching freight train or like a jumbo jet, something much louder than kind of the normal crashing of the wave. Or you might just see the water kind of bubbling or frothing or behaving abnormally. If it's doing something that kind of makes you go, that's weird, or that gives me a weird feeling in my gut, maybe get to high ground. And if a tsunami is not on the way, you've practiced your evacuation route. Now, for distant tsunamis, again, less of a threat, but still something we want to be aware of for the outer coast. As I said, Alaska really is our biggest threat. Alaska has a lot of earthquakes. They also have a subduction zone, much like ours, a little more active. And they usually kind of kick off a magnitude 8 or higher once every about 13 years. Now, the thing about a major earthquake in Alaska, it looks like my screen went dark. That's weird. There we go. The thing about an earthquake in Alaska is we're not going to feel that ground shaking. So very important that we get tsunami alerts that we know something is on the way. Now, when we plan to something coming from Alaska, we look to an event that's very similar to the 1964 Alaskan Good Friday earthquake and tsunami. Really, the only difference is that it's the epicenter where that earthquake occurs is just a little bit modified so that tsunami is really hitting Washington as square as possible. But it's, again, kind of a 9.2 magnitude earthquake, just like it was in 1964. So very, very similar to that event. Now, that tsunami that is caused by that earthquake reaches our outer coast in about 3.5 to 4 hours, kind of depending on the location. Something to keep in mind is that unlike Cascadia, which starts as a trough or the wave pulling out from the shore for us, the wave crest is leading for something from Alaska. So we would not get that warning of, oh, there's something pulling away from the shore. That's a tsunami. We would just have that sudden rising wave coming at us. So again, that's why it's so important that we have those official alerts to warn us. We don't right now have complete Alaska modeling for the whole coast, showing what that inundation would be for that 9.2 scenario. We do have limited modeling though, and the Washington Geological Survey is working on modeling for the whole coast. So we will have an idea of what that inundation looks like for that distant event. And the limited modeling that we have done, such as the graphic here for Westport Marina, does show that we still get several feet of inundation, which is enough to put people in that area in danger. So we want to make sure that folks are getting out of those areas if we know something is on the way. And now to give you an idea of what those distant tsunami impacts can look like, for 2011, local event for Japan, very devastating. It was a distant tsunami for the rest of the world, for the West Coast. We saw about 7-foot waves in some parts of California and Oregon. We were very lucky here in Washington not to see any damage. California saw about $100 million in damage to recent tsunami in 2022 was the Tonga tsunami caused by the Tonga volcanic eruption. Again, we were very lucky here in Washington not to see any damage. We saw waves of about a foot, and California saw waves of about 3 to 4 feet. We got some great footage, thanks to folks on Twitter, of what those waves look like in California. And I really like these two videos, the one on the left especially, because it shows that those waves have a lot of oomph to them, even though they are potentially only 3 feet above kind of what the normal tidal range would be. You can see that there's a lot of force in them. You wouldn't want to be on that beach with those waves crashing into you. And then the video on the right, I really like. It's this marina that's been inundated, and it just looks like it's flooded. It looks like that water is very still and serene, and like you could just wade through it. But one thing to note when you see that video zoom in is that back parking lot, you can see that those waves have started to lift up some of the parked cars and move them, which means that there is enough force and movement behind those waves to lift heavy vehicles. Something else to keep in mind, you can't see it so much in this video, is that because it's a marina, you have, fuel, you have electricity, you have things that are going to make that water, even if it is placid, still very dangerous to be in. So even though they didn't see a ton of inundation, people didn't have to head for the hills, those waves were still very dangerous for folks. So when we especially are thinking about distant tsunamis and how we get warnings from them, we rely on the tsunami warning centers. So there are 2 of them, the Pacific Tsunami Warning Center in Honolulu, which generally covers kind of international partners as well as Hawaii, and then the National Tsunami Warning Center in Palmer, Alaska, which covers essentially all of North America, including the West Coast and Washington. So if you are looking for information about, tsunamis in Washington, maybe we're under a tsunami alert and you want more information, you're going to want to look to the National Tsunami Warning Center. Any information they are pushing out is going to be applicable to us. And then we have 4 different tsunami alert levels that could go out if there is some sort of tsunami event going on, or maybe a big earthquake somewhere in the Pacific Ocean. Most often you will see tsunami information statements. Basically, those go out when something of note has occurred, and the National Tsunami Warning Center just wants to make sure that everybody knows there's nothing to worry about. So maybe it's a smaller offshore earthquake, but it's really close to us. So it's, off of Washington's coast or off of California's coast, and they know people are going to be paying attention. They might release an information statement to say, yep, we know that this earthquake happened. It wasn't big enough to cause a tsunami. You guys are good. Or it could be that there was a very big earthquake somewhere else in the Pacific that maybe did generate a tsunami, or was, possible to generate a tsunami locally over there, but not large enough to impact us. They may send out an information to us. Are usually released when something of note has happened and the warning center needs more information. So maybe Alaska's had a big earthquake. It's potentially large enough to generate a tsunami, and they're waiting for a little more information. They think, we might need to put Washington into an advisory or a warning, but we're not sure yet. We want you to, the Washington public, to be prepared to take action. When we're under a watch, that watch is always going to change. It's either going to be upgraded to an advisory or a warning, or it's going to be canceled completely. Now, advisory and warning, those 2 alert levels really are okay, either we know something's on the way, or we're pretty sure something's on the way, and you may need to take action. Tsunami advisory is what we were under for about, I think, 17 hours during the Tonga tsunami. That really is an alert level aimed toward the maritime community and folks who are, for whatever reason, are going to be on the watch. We usually, with an advisory, are expecting maybe strong currents, waves of about 1 to 3 feet, not a lot of inundation, but we want to make sure that folks are, off the beaches, out of the marinas, off boats or kayaks, that kind of thing, and just staying away from the shore. With a tsunami warning, that's the big one. That sets off all the bells and whistles. Either we know something big is on the way, maybe from Alaska, or something has happened, maybe a big earthquake, that has happened close enough to Washington that regardless of whether we're sure or not, it's so close that we need to act because we need to get folks to high ground. So when a tsunami warning is released, like I said, that sets off the bells and whistles. You might get an alert on your phone. You may hear over radio or on TV, you might see, you know, the scrawler going by. If you have a NOAA weather radio, that will definitely be making noise and letting you know something's up. If you are on the coast and you're close enough to a tsunami siren, you'll hear those go off. And tsunami warnings really mean like, we are expecting waves of above 3 feet, really powerful currents. We want folks out of the inundation zone. So how do you get those official alerts? We want to make sure that if something happens, that we can get a hold of you in many different ways, because you just never know when you might have internet issues or technical difficulties. So it's good to have multiple ways to get all kinds of alerts, especially tsunami alerts. You might get some on your smartphone, like Brian was talking about. That's how you get wireless emergency alerts, just the same way that you get Amber alerts. You can also sign up for local alerts. You can download apps, that kind of thing. That's a really great way to get them. You might have, you know, TV or radio. You might see something there if you're tuned to a local station. Not going to work if you're watching Netflix or you're streaming, something like that. NOAA weather radios are a great way to get alerts. The nice thing about those is that they can be programmed kind of like a smoke detector, where you don't have to have the radio part actually audibly making noise all the time, unless you want to listen 24/7 to, you know, weather radio alerts. You can have that turned off so that the radio only makes a sound when there's actually an alert that you need to pay attention to, in which case it'll make a nice loud tone, just like a fire alarm would, to wake you up and let you know that, you know, hey, you need to pay attention. Maybe there's a tsunami warning, maybe there's some other alert, you know, storm or whatever for your specific area. So those are great to have if you don't have one. And finally, we have the, you know, tsunami sirens. So if you were on the beach and maybe you're in an area where, you know, there isn't great cell coverage, maybe your phone's roaming or dead or whatever, you're not near a TV or a radio, you have no other way to get an alert. Those sirens are kind of that last resort system. We want to make sure that you're still going to be able to be informed. I've got some third-party apps listed here. If you are in Washington or Oregon, really recommend the NVS Tsunami Evacuation app. That's something that you can download for either Android or Apple systems. You can also look at it in the browser. The great thing about that is, one, it's for both Washington and Oregon. It pushes tsunami alerts. Not a lot of other apps do that. So if you've got it downloaded, it will let you know, it'll push a notification to you if we are suddenly under a tsunami advisory or something like that. And it also has all of the published tsunami evacuation maps for Washington and Oregon. So if you are going to visit Long Beach this weekend, when you get there, you can tell it, hey, I'm in Long Beach, and, you know, click your location and it will pop up with the, you know, local maps that you can download. So that's very handy, especially if you travel along the coast a lot. But if you go to .gov/alerts, like Brian was saying, that's a really good kind of landing page for all different kinds of alerts in Washington. And I do want to touch very briefly on the tsunami sirens themselves. So we have over 120 tsunami sirens along the inner and the outer coast. They are an audio alerting system, although we are working to get flashing blue lights on them for those who are deaf or hard of hearing. And they have an approximate audio range of about a mile. It really depends on kind of the weather. If there are any, you know, physical barriers between you and the siren. They are not intended to be heard indoors, although if you're close enough to them, sometimes you can hear them indoors. But like I said, they're really intended for folks who might be right on the beach, who have no other alerting methods. They really are sort of that last resort. We want to make sure that you know if something's on the way. here at Washington Emergency Management Division, we are the ones who, if Washington is under a tsunami warning, we will activate the sirens. Locals also have that capability as well. And we test the sirens all the time to make sure that they are working and try to get them fixed as quickly if they are not. We test them daily with a silent test, monthly on the first Monday of the month with the Westminster chimes. So if you're ever around one of the sirens on the first Monday of the month, you'll hear them go off with the Westminster chimes, and then a voice message in English and Spanish. And then we test them yearly with the actual wailing sound on the Great Washington Shakeout, which is the third Thursday in October every year. So this year it's October 17th. So at about 10:17, you're going to hear the sirens do the actual wailing sound. So just a heads up there. And I know this is not the greatest graphic, so it's hard to see. This is on our website, but this is kind of the locations of the sirens. Because they are intended to alert us for distant events, they are really only in locations along the outer coast and then along the strait where we can expect a distant tsunami to have impact. So we don't really have them in the South Puget Sound, really only where we think there may be waves from that, from a distant tsunami. And now, what do we want you to do if you feel that ground shaking or if you get a tsunami alert? Well, first, if there is ground shaking, we want you to survive that earthquake. So like Brian was talking about, no matter where you are, we want you to drop, cover, and hold on to protect yourself from being either injured by debris or thrown to the ground if that ground shaking is hard enough. So even if you're just on the beach, we want you to, lower your center of gravity, cover your head and neck, make sure that you can survive that shaking. Then once that shaking stops, or whenever you feel like it's safe for you to move, we want you to grab your go bag, because hopefully you have one with you already, and we want you to head inland to high ground. If that ground shaking is your warning, if you hear the sirens, if you get an alert on your phone, whatever, that is your cue to go to high ground. We don't want you to waste time checking for other alerts, asking someone, hey, did you get an alert? Did you? Oh, I need to check on Twitter, whatever. That is your warning. Don't waste time double checking or confirming or, calling the police to see if they know more. Get to high ground. And the very worst case, for some reason, it's not a tsunami and you have practiced your evacuation route. Now, we want you to be prepared to walk. Especially for a local earthquake and tsunami, something like Cascadia, your evacuation route may be blocked or damaged. There may be downed trees or buildings. The route itself, the concrete may have moved and settled strangely during liquefaction. It may not be accessible for cars. So we want you to be prepared to walk if you have to. For distant events where nothing should have happened here and everything's fine, we still want you to walk if possible. One, because you're not going to have to go as far. There'll be less inundation. Two, because we want to leave the roads open to emergency vehicles, people who can't evacuate on their own, or for people who are having other emergencies. We want to make sure that just because we're having people evacuate doesn't mean that, we want folks to be able to get to the hospital if they need to get to the hospital, or fire trucks to be able to get through if they need to get through. So planning to walk to high ground is your best bet for a lot of reasons. And then once you reach high ground, we want you to stay there. Tsunami waves can continue for anywhere from 12 to 24 or even more than 48 hours. And especially if there has been a lot of damage in the inundation zone, it may not be safe for you to re-enter. So we want you to wait at high ground until local authorities, so your local emergency management or local fire police, tell you that it's safe to return, because it could be that there's still standing water. There could be things on fire. They could be doing search and rescue. It could be that you can't return to that area for a while. So wait until you're told that it's actually safe to return. And evacuating may take longer than you think. It's important to know what your closest evacuation route is, and knowing if there is a map and evacuation routes for your area. Knowing, having a go bag with you so that you don't have to waste time packing and you can get out very quickly is really important. Having it in an easily accessible place, not somewhere where, you know, in the trunk of your car. Now you go find your car keys post-earthquake to get it out of your car. It's going to take longer than you think. So having it as streamlined as possible is very important. Practice, practice, practice. It all sounds good in theory until it's the middle of the night and you've just spent, you know, 6 minutes of intense ground shaking, hiding under, you know, a piece of furniture, and now it's dark and you're a little wigged out. Having practiced that route, knowing it by heart, will mean that your body goes into action even if your brain is still not quite clued in. You can find any maps for Washington at mil.wa.gov/tsunami, and you can also look up any address, you know, your home address or work address on WA-DNR's geoportal, which I'll share in a little bit, to see if there are any maps for your area. We're always working on publishing more each year, but we're trying to get all of those high-risk locations. And then just to familiarize you with what the different kind of tsunami signs you might see out in the wild are, you are probably most familiar with tsunami evacuation route with the arrows pointing to which direction you should go, but we also have assembly area signs showing, you know, this is high ground, this is a place where we want you to assemble. There might be supplies there. There will certainly be other, you know, people going there. There are also tsunami hazard zone signs, just letting you know that you are within the inundation zone and that if you feel that ground shaking or you get an alert, that's an area you need to leave. The leaving tsunami hazard zone and entering tsunami hazard zone signs are still pretty new, so you may have seen them around, you may not, you may see more of them in the future, but those kind of serve the same purpose. They're meant to let you know when you're coming into a hazard zone, when you are leaving that hazard zone, so you know that you are now at high ground, just to give you a better idea of what that hazard zone looks like. Now, what if you can't evacuate before those first waves arrive? What if it just isn't possible? One of the great products from the Washington Geological Survey are these tsunami evacuation walk time maps, which not only show you your evacuation route, but also, you know, wherever you are on the map, how quickly or how long it takes to walk from that area to the closest high ground. And there are a lot of places on the outer coast, like this part of the Long Beach map here, where you might be somewhere that says it's going to take you 75 minutes to walk to high ground, and that estimated wave arrival time is 15 minutes. Even if you are running as quickly as you possibly can and you're a trained, you know, marathon runner, the math may just not work out. So what do we do in those situations? Well, that's where vertical evacuation comes in. We have to bring artificial high ground to those areas that don't have normal, you know, natural high ground nearby. And that's something that we are working on as a state, as local jurisdictions, as much as possible. We have 2 vertical evacuation structures in Washington. We need anywhere between 58 and 80 more. So we're making slow progress, but we're working on it. The first vertical evacuation structure in all of North America was Acosta Elementary. We now also have the Shoalwater Bay Tribes Tower, and the cities of Ocean Shores and Westport have received funding for towers and are also working on that. So we are aware that we need these things. We know where we need them. It's just a matter of getting the funding and getting them in the ground. Something else we are working on through our office is tsunami maritime response and mitigation strategies. So take, you know, really high risk ports, harbors, and marinas, and looking at their very specific, you know, their site risk and what we can do to improve not only their tsunami maritime response, but to mitigate that risk. And so that's something that we've been working on for several years now. And on our website, you can see those strategies. We're about to publish a couple more. And that's where some of that really site-specific mapping and modeling that you'll see in some of our presentations comes from, is from those strategies. So if you live in those areas, or if you have a boat or something at one of those marinas, I really recommend taking a look at those. They're really interesting and hold a lot of promise for how we can mitigate some of the big impacts from our tsunami hazards. In addition, we also have the Washington State Tsunami Boater's Guide. So this is geared specifically toward Washington mariners, provides a lot of different hazard guidance specifically for tsunamis, the kind of information you need to make decisions if you're on the water, whether it's kind of a local tsunami or a distant tsunami, whether you are on the outer coast or you are in the inner coast, because those are very different places. The risks are very different. Your options could be very different. So very good resource. If you want to just look at the electronic PDF of it, that is also on our Tsunami website. And then there are also physical copies. So let your local emergency management know if you're trying to hunt one down, or we're also happy to mail one out to you. But that is a newer resource that I think is very helpful. Now, I know we don't have too much time left, so I'm going to carefully fly through the preparedness part. But we've been talking about a lot of different disasters that could have small impacts on you or could have very big impacts on you. And really the most important thing, no matter what kind of hazard you're thinking about, is that you may need to plan to be on your own for a while, especially when we're talking about something big like Cascadia, where much of our state will be impacted to one degree or another. There's a good chance that wherever you are, you may be on your own for a while, or you may be relying on your neighbors, your community, while we at the state and federal level are trying to get folks out to you. And so that's why it's so important to be prepared. And hopefully you have been thinking throughout the last 2 hours-ish about how prepared are you? We're all somewhere on our preparedness journey. Nobody is completely unprepared, and nobody is done preparing. It's a continuum that we are all always working on. But hopefully you've been thinking about, how am I going to get alerted to, these different hazards? Do I have a family emergency plan? Do I have a go bag, and where am I putting it? Is it going to be accessible for me? Do I know my evacuation routes, and have I practiced them? How am I going to communicate with my family? And if you can answer all of those questions, hopefully you're starting to think about then, how am I involved in, neighborhood or community preparedness? How am I making sure that the people around me are prepared too? Because we're going to be relying on each other. So that first step, which we're going to be able to check off today, is learn your hazards. Knowing what can happen wherever you are, whether it's where you live, you work, you play, you visit, that kind of thing is really the most important thing. If you know what might be able to happen, then you can prepare for it. So we've been dropping links all day, but if you have missed any of them, we've got pages for our volcano hazard, our earthquake hazard, and our tsunami hazard, as well as others. These are really great resources. We've got a ton of different information there. So I definitely recommend checking those out if you have not yet. And then the Washington DNR Geologic Information Portal is a really great resource if you're not sure what hazards you have in your area. You can type in an address and it'll pop up kind of all of the different types of hazards that you might have in that area, along with any mapping and modeling that they've done. It's not the most user-friendly, but if you have questions, reach out to us. We're always happy to help with that. Second, we want to make sure that you have a plan for when that hazard occurs or when something bad happens. So how are you going to communicate? How are you going to evacuate if you need to? And how are you going to reunite with your family or friends or whoever it is that you need to reunite with? We want to make sure that you have a plan with your loved ones, including pets, a workplace plan. So hopefully your workplace already has one, but do you know what that plan is? Is it practiced? Are you aware of it? And then plans for other places that you spend a lot of time. So do you have kids that are in school? Do you spend a lot of time at grandma's house? Or do you volunteer somewhere and you know that on the weekend you're going to be there for maybe 10 or 16 hours a day? Having that plan, knowing what everybody else's plan is, and then practicing those plans is so important. A part of that plan is signing up for local alerts. I know we've been pushing that a lot. Here's your opportunity again. Go to our mil.wa.gov/alerts page. We've got a bunch of different kinds of alerts there to sign up for, including local alerts. Really important to be signed up for alerts through your county, your city, if they offer that, or your tribe. Those are going to be the alerts that provide you that really site-specific or location-specific information. Good to be signed up for others as well, but those local alerts are going to tell you what you really need to know depending on where you're located. And then finally, making sure you have supplies. So when we talk about building kits, what we're really talking about is making sure that you have stuff for if you need to shelter in place for a while, if you're stuck at home, and stuff if you need to, get out and get gone fast. Especially, I'm in kind of a rural area in Western Washington, so I am no stranger to power outages and snowstorms where I can't even get out of my driveway for several days. So being 2 weeks ready, at least, having enough stuff at home where if you can't leave your house for a while, that you've got water, if you don't have running water, that you've got food that you can easily prepare without power or heat, anything like that, and any other supplies that you need, medical, pet, stuff for your kids or for, your elderly family members, anything like that. Having at least 2 weeks of that is really important, just in case, the worst of the worst happens and, rescue or, if authorities can't get to you in less time than that. If you're in a really rural area, if you're on the outer coast, if you're in an area where you know that it's one road in and out over a old sketchy bridge, something like that, you might want more than 2 weeks. You might want a month's worth or something like that. But at least that 2 weeks is going to be pretty good as a starting place. And then we also want you to have, a go bag or grab and go kit, emergency bag, whatever you want to call it. That doesn't need to be 2 weeks worth of stuff. That's a couple of days worth of supplies to get you from point A to point B. So if you wake up in the middle of the night and your house is on fire and you got to go, you can grab that bag knowing it's got a little extra medication. If that's what you need, it's got some fresh clothes in it, identification, whatever it is that you need to get to a shelter. Or out of the tsunami inundation zone and to shelter, to a friend's house, whatever it is. It's got to be, something you can carry. So, if you are less able, then that's going to really define what your go bag looks like. But it doesn't have to be, 20 pounds of food and water. It's just stuff to get you to point B. Our Prepare in a Year site has a lot of really good resources for putting supplies together, for getting, your home or your workplace, wherever it is that you spend a lot of time together. Preparedness doesn't have to be something that you do all at once, that costs a lot of money, that's super, super stressful. It can be just a little step you take once a week, once a month, every time you're at the grocery store, bite-sized chunks. Again, preparedness is a journey that we are all on. So you don't have to feel like you have to do it all right now. And finally, think about who in your community is going to need extra help, whether that's because we're all stuck indoors or because we all need to leave very quickly. If you feel like, yeah, I'm prepared, I've got a month's worth of food and my family knows what to do, et cetera, start thinking about, who on your street or in your community is not going to feel that confident, and maybe start reaching out to them and see what you can do. And lastly, are you registered for the 2024 Great Washington Shakeout? Shakeout is the largest earthquake and tsunami drill in the world. It is global, worldwide, not just in the United States, not just in Washington. Third Thursday in October every year. So this year it is at 10:17 a.m. on October 17th. We're all going to practice drop, cover, and hold on, and hopefully some other, earthquake or tsunami related thing. Might be practicing your evacuation route. Keep in mind, if you are on the coast, 10:17. All tsunami sirens will be tested with the actual wailing sound. They will make the loud, scary sound. Please do not call 911. They are supposed to be doing that. Anybody can participate in Shakeout, whether that's individuals, families, businesses, nonprofits, schools, your community group, your book club, your wine and dine, whatever. If you are going to be practicing Shakeout, please register. We want to know that you're taking part. That helps us understand who is taking part, how many, where are you, that kind of thing. So please register. You also don't need to take part or do your Shakeout thing on October 17th. That's when most people do it. That's the day that we put year, and you can do whatever is going to help you be more prepared. So please, 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 please register. If you're having trouble registering, you can't remember your login, or you want some ideas about how to register, that kind of thing, please let us know, because our team can definitely help with that. And that is it. I know we are coming up on time. Please know, like Brian said, we talked about a lot of heavy stuff today, but you can survive if you get prepared. We absolutely know that that is true. We believe it, and our team is here to help. Got some great resources here. We will, as we said, this is being recorded. We will post it on our YouTube. TVW has also been streaming it, so I believe they are posting it also. If you have any questions that we can't get to, or if you need to drop off before we get to your questions, please reach out to our email. It is public.education@mil.wa.gov. That reaches our whole team. We love answering questions. We will probably respond with a several paragraph email with lots of links and resources and things like that. So please don't hesitate to reach out with any question that you might have. And with that, I know Brian has been posting things in the Q&A. Brian, do we have any questions?
I did not see any questions that we were unable to answer, but Alyssa, one you might be able to address better than me is the state posting tsunami evacuation signs along the coast?
That is a great question. So yeah, we actually just completed a 2-year assessment of all of our mapped evacuation routes. So that was a little over 1,050 miles of evacuation routes. And part of what that assessment did was we walked routes and we took information, GPS coordinates everywhere that we needed more signs. So anywhere where, you couldn't see the next sign, you couldn't see the last sign, and it wasn't obvious where to go next, we said we need another sign here. And it turns out we need a lot of them. Not surprising, we knew that. But now we know where we need them. And so we are working to get signs out there, to get them installed, to fill all of those gaps. And as we continue to, map more communities, we will continue to get signs out there. So that is something that we are working on. We are trying to help at the state level with kind of funding that, providing signs for free, helping to cover installation costs and things of that nature, so that we can speed up that process. Because again, we know we need a lot more signs than we have, but we are aware that there are many, many gaps along our evacuation routes, and we are working on that. So thank you for asking that. That is a great question.
Yeah, thank you so much. And I believe I was able to answer the other questions in the chat, but if anybody else has any questions, please, again, feel free to reach out to publiceducation@mil.wa.gov with a dot in the middle, as you can see on the slide. Yeah, thank you, everybody. Thank you, Alyssa, for the presentation and for going with slides. Again, thank you for patience with technical difficulties. Thank you to WASERV and CERT for putting this on. Yes. And we hope you've all had a chance to learn a lot. And thank you so much for bearing with us today.
Yes, thank you, everyone. And again, we will post this to our YouTube. So if you missed any part of it, it will be up there. We've got a lot of other good videos there as well. Thank you all so much. And with that, I will end the presentation.